Okay, good evening, everyone. Welcome to O-Level Physics. Today, we will start on the topic, Chapter 7, okay, which is the kinetic particle model of matter. Okay, my name is Mr. Chu. Okay, today is 7 August, and welcome to the class. Okay, so this topic is the same as what you have learned in chemistry. Okay, so if you are studying chemistry, which I believe all of you are, okay, this topic shouldn't be that difficult. Okay, it shouldn't be that difficult because it's the same topic as your chemistry kinetic theory of matter. Okay, any problem so far? Any question for me? Okay, so before I go into this topic, okay, so today I'm going to spend one lesson talking about what you need to know. Then the next few lessons we will be practicing past year exam question. Okay, regarding this topic. Okay, so let's begin. Okay, so let's show you how's for pure physics, for your year onwards, your year is a new year. There are lesser topics compared to your senior. Okay, however, don't be too happy. Some of the topics are lumped together. So actually, you are learning the same thing plus radioactivity. Okay, your seniors are all not learning chapter 20. So some of the topics here are crammed together. For example, sound. Okay, for wave, there's a topic on sound. But now the sound is lumped into chapter 10. Okay, then in section 2, there's a topic called mass, weight, and density. Okay, now the topic is gone, but it's not disappeared. It is now inside dynamics. Okay, so don't be so happy that your number of topic is lesser than your senior. Your senior has 24 topics. Okay, but you have now 20 topics. Okay, but don't be too happy. Okay, so today we're going to start off the section or the branch called thermal physics. Okay, so anything that got to do with temperature, got to do with heat, okay, will be all covered under thermal physics. Okay, so for thermal physics, there are 3 topics that we're going to learn. Okay, you're going to learn what is you're going to learn the kinetic particle model of matter. So this is just one of the many model of how we describe matter, because matter are very small. Okay, so there are different models that used to describe it. So what you're going to learn is this model called kinetic particle model. Okay, so you're going to also learn after that thermal processes. Okay, thermal processes would be um, things like how you heat things up. Okay, how does your object change state and so on. Okay, then you're also going to talk about thermal properties of matter. Okay, so these 3 topics got to do with thermal physics. Okay, so let's skip to chapter 7. Okay, so maybe you all can take a minute to read the overview. Okay, read the overview. What thermal physics is all about. Okay, once you have finished reading the 3 paragraph, give me a yes reaction. Okay, thank you, Ichi. Uh, Okay, so Xuan, Wei Hong, and Siren, have you finished reading the three paragraph? Okay, very good. Okay, so this is just an introduction on what thermal physics is about. Okay, so the first thing before we talk about thermal physics, okay, we need to understand the kinetic particle model of matter. So what is this kinetic particle model of matter? I want you all to write down somewhere or type it out and send to me. Okay, so the kinetic particle model of matter is a theory that states that this model is made up of tiny particles that are in continuous motion. Okay, so we are going to use this model to explain the states of matter. Okay, we are going to explain the properties of matter. We're going to also explain temperature and pressure due to this because of this model. Okay, so for topic number 7, okay, it is split into two subtopics. Okay, states of matter as well as kinetic particle model. Okay, so all of you are expected to know, okay, there are 3 states of matter. Okay, so let me just highlight them to you. There are 3 states of matter: solid, liquid, and gases. Okay, so you all need to know there are 3 states of matter, but besides knowing the 3 states of matter, you also need to know the physical property of the 3 states of matter. Then use the kinetic particle model, okay, which is using tiny particles that are in continuous motion. This model to describe these 3 matter, okay, to describe their physical property due to the arrangement and motion of the particles, as well as the forces and the distance between the particles. Okay, so far, are you all with me? Okay, so this topic, you have learned this already in chemistry. Am I right to say that? Okay, if you have learned this in chemistry, give me a yes reaction. If you have not learned it in chemistry, give me a no reaction. Okay, very good. Okay, so I'm going to summarize the properties of solid, liquid, and gases. So let me just change the thing to a whiteboard. Okay, so there is a 3 state of matter that you're going to go through. Okay, so in O-level physics, you are only need to learn 3 states. Okay, you need to only learn 3 states of matter. Okay, so I'm going to write this down. If you want, you may want to copy. Okay, so by now, you are learning in primary school, there are 3 states of matter. There's solid, okay, there's liquid, and there's gas. Okay, so we're going to talk about these 3 states of matter. Okay, so first of all, okay, let me just continue drawing. Okay, let me do this one. Okay, I'm going to write down, okay, the arrangement and the motion. Okay, how are they arranged and what is the motion? Okay, what is the motion that the solid, liquid, and gases have? Okay. Okay, so for the three states of matter, okay, so all of you have learned in primary school. Okay, you all need me to summarize in primary school. Okay, you actually know that solid has a definite shape and a definite volume. Correct? Okay, it has a definite shape and a definite volume. Liquid has a definite volume but do not have a definite shape. Okay, and gases do not have definite shape and definite volume. So we are going to use kinetic model to explain why solid has a definite shape and volume, whereas why gas do not have definite shape and volume. Okay, so we're going to use the kinetic model of matter to explain. Okay, so we're going to use the kinetic model to explain at the particle level what's happening. Clear so far? Okay, so we're going to talk about at the particle level what's happening. Okay, when I talk about the word particle itself, particle actually can refers to atoms or molecule. Okay, so most of the things that we see around us, they are all in molecules, unless we are talking about like matter or talking about noble gas. Okay, if not, the rest of the items that we are talking about, each particle that you talk about are either atoms or molecules. Okay, so things like proton, neutron, electrons. Okay, this is what you learn a lot in chemistry. Okay, proton, electron, neutrons, these are subatomic particle. Okay, so right now we are talking at the particle level. Okay, not the subparticle level. Is that clear? Okay, so the particle itself can be solid, can be liquid, can be atom or can be molecule. Okay, so whatever that we are going to explain here, okay, will be at the particle level for now. Okay, first of all, for the solid itself, what is the first arrangement that can you think of? Okay, first of all, they are closely packed. Okay, arranged in a regular pattern. Okay, least energy. Okay, the particles have the least energy. Okay, okay so far? Okay, they are closely packed, arranged in a regular pattern and the least energy. So if I were to draw solid particles, they'll be like this. They will be all in a very regularly organized. Okay, in a regular kind of arrangement. Okay, very regular. Okay, and they are very closely packed, hardly anything between them. Is that clear? Okay, so can you see this? This is something like a solid. Okay, at the particle level, it looks like that. So the particle are each of the particle is this orange, is represented by this orange circle. Clear so far? Okay, so each orange circle can be either an atom or a molecule. Is that clear? Okay, so therefore they are closely packed. They are arranged in a regular pattern. Okay, so they are closely packed, arranged in a regular pattern, and they have the least energy. Okay, solid has the least energy. And therefore, because they are closely packed and arranged in a regular pattern, so from here you can tell that solid has a fixed volume and a fixed shape. Is that clear? Okay, then what are the motion of the particles? The motion of each single circle. How does the particles actually move, okay, among them? Okay, so first of all, the particles itself, okay, the particles itself vibrates about the fixed position. Okay, so all of this so far, you all have learned in chemistry, am I right? Each particle or each atom or each molecule, they vibrate about fixed position. Okay, they do not actually move around. They do not move around each other. They vibrate about the fixed position. Okay, so they are held in position by strong attractive forces between them. Okay, so between them, they are very strong attractive forces. Okay, so these forces and this energy are different thing altogether. Okay, they are different thing altogether. Okay, solid has the least energy. Okay, they are vibrating, but they are not moving fast around. Okay, so they have the least energy. They are all sitting at the location. But between them, they have actually very strong attractive forces between them. Is that clear? Okay, now for liquid. Okay, I'm sure you all know how to draw a liquid. Who want to draw the circle in the liquid one? Okay, raise your hand. Anybody want to draw the liquid and as guess? How does it look like? Who would like to volunteer? Anyone? Nobody want to entertain me? Okay, so we are going to talk about observable properties. So based on this theory, okay, at the particle level, okay, where the solid particles are vibrating about its fixed position and they are closely packed, and because they are arranged in a regular pattern, okay, so they are closely packed. So among the three of them, because they are closely packed, therefore, okay, it should have the highest densities. Okay, highest density among these three. Okay, do you agree with that? And because they are arranged in a regular pattern, so you have a fixed shape. Okay, fixed shape and fixed volume. Okay, are you able to appreciate this? Okay, so in primary school, okay, you do not learn density. You only learn shape and volume. Okay, solid has a fixed shape and a fixed volume. And you do not have a reason why. Okay, you just need to, you actually know this based on your daily observation of how solid looks, feel, okay, and yeah, how it feels like, how it looks like. Okay, but when we use the kinetic model of particle, kinetic particle model, we use the how the particles are arranged and how the particle move to explain why solid has fixed shape and why solid has fixed volume. Okay, so the new thing that you learned today compared to primary school is using particle theory, okay, the kinetic particle model to explain why solid has a fixed shape and a fixed volume. Okay, up to here, are you all very clear or are you confused? Okay, if you are clear, give me a yes reaction. If you are confused, give me a no reaction. So far, okay, right? And you have learned this in chemistry. You have learned this in school for physics. Okay, for Xiren and sorry, for Zixuan and Yuqi, yeah, I learned this in school, so it should be easier to understand now. Correct? Okay, so now, can someone draw the liquid and the gas? So I will explain to you all uh, about the how liquid particles are arranged and how the liquid particles are moving. Anybody want to volunteer to draw? Hey, nobody want. Well. Okay, so first of all, solid is closely packed. How about liquid? Liquid is also closely packed, but it's slightly less closely packed than solid. Is that clear? Okay, it's slightly less closely packed. And it is arranged in an irregular pattern. Clear so far? There's no regular pattern at all. So for liquid itself, the particles are still closely packed, but not as closely packed as solid. It's slightly less closely packed compared to solid. And however, they are not arranged in a regular pattern. Okay, so let me, you don't want to draw, then I draw lah. Then you have to wait lah. Okay, so for liquid they are closely packed, but it is not regular pattern. Okay, they are closely packed. So imagine each of the circle is either an atom or a molecule. Okay, there is no fixed pattern at all. So can you see that? But they are also close to each other. So they are closely packed. Okay, so therefore, but they are not as closely packed as solid. Okay, so the density itself, okay, density here, can you tell? The density is slightly lower compared to solid. Clear so far? Okay. Hey, my this one doesn't look nice. The circle all different size one. Okay, does it look better now? Okay, so for liquid itself, it's not a regular shape, it is an irregular pattern. Okay, they do not vibrate about fixed position. Okay, the particles actually slide over each other. Is that clear? So they do not keep in a fixed position. The particles actually slide over each other throughout the liquid. Okay, and the attractive forces between them is slightly weaker. Okay, the attractive forces between them is slightly, okay, the attractive force between them is weaker, okay, than a solid. Does that make sense? Okay. And then, of course, if this is the least energy, a liquid will have more energy. Okay, a liquid will have more internal energy. So therefore, the temperature is higher. Clear so far? Okay, so for density itself, it is lower. So from this theory, okay, so from this theory, can you tell that the density is high? Liquid density is still high, but not as high as solid because it is slightly less closely packed. Okay, then the next thing will be, okay, because they are closely, they able to slide through each other, the forces between them is still strong. Okay, is still strong, so they have a fixed volume. Okay, the liquid has a fixed volume because the forces between them is still strong. They are still close together. They only slide over each other. They don't vibrate about its own position. The only thing difference is that it does not have a fixed shape. Okay, because the particles itself slide over each other. Okay, so you actually can move around the liquid itself. Clear so far? So from this explanation, due to the arrangement and motion of the kinetic particles in a liquid, okay, due to the arrangement and motion of the kinetic particles in a liquid, can we explain why the volume is fixed and the shape is not fixed? Okay, if you understand this perfectly well, give me a yes reaction. Ray Ho and Yu Qi, are you okay? Okay, let me draw the gas. Gas very easy lah. They're all far, far apart. Okay, so for a gas, the particles, okay, are far apart. Okay, so they are no longer closely packed. Okay, they are no longer closely packed. They are now very far apart. Okay, arranged in an irregular pattern. Okay, arranged in an irregular pattern. And it has the most energy, okay, among the three states. Okay, so from here, can you tell that they are very far apart? So therefore, their density will have to be the greatest or smallest. Okay, you have to have the lowest density. Is that clear? Okay, they are actually very far apart, so their density is the lowest. Okay, their density is the lowest. Okay, because they do not have because they are in a very irregular pattern. Okay, so they have no fixed shape. Is that clear? And because there are a lot of space between them, okay, you can actually compress the gas or expand the gases easily. Okay, so therefore there is no fixed volume. Okay, so can you use the kinetic particle model to explain this property of the solid, liquid, and gas? Are you all clear about this so far? Okay, now, how does the particle in a gas actually move? How does it move? Okay, so they can actually move freely. They move freely, same as liquid, they can move freely. But for liquid, it is actually slide over each other freely. Okay? Okay, can move freely in any direction. And the attractive forces, okay, they actually have weak attractive forces between them. Okay, they have weak attractive forces, okay, between the particles. Okay, so all these arrangement and motion of the particle explain the property of the solid, liquid, and gas. Are you okay? So before today, if you have learned this in chemistry, did I actually help to explain better or no difference? Okay, so can you write down in the chat how well do I try to explain this compared to what you know before? Okay, is it actually a bit better or there's no difference? So can you explain to me? Then can you give me some comment? Thank you, Shixuan and Xiren. Rui Hou and Yiqi, are you all okay? You want to take a screenshot of this? If you want to take a screenshot, do that quickly. Take a picture, take a screenshot. Then I will continue in a while. Hello. Ray Hong and Yi you how am I explaining this to you? Okay, so the model of matter, what you see so far here, okay, are just the particle. Okay, there are three components of this model. Okay, first of all, the spheres that you see represent the particles. The particles in this case are either atom or molecule. Okay, so the spheres that you see down here is actually the okay, that represent the particles. Okay, then between them, okay, between the particles, okay, let me show you all. There are actually forces. Okay, there are actually forces between each of them. Can you see that? So there are actually forces between each of them. Clear so far? So this blue line that I draw are the forces between them. Okay? So the forces, in this case, in a solid, the forces between them is the greatest. Is that clear? Okay, it has a strong force between them. Okay, so in a liquid itself, there are also forces between them. In gases, the force between them is actually very minor, very small. So they have actually weak attractive forces between the particles. Okay, so for solid, there are actually forces between them. Okay, and the forces between them among the three states is the strongest. Clear so far? Okay, then in the previous topic of energy, okay, we talk about this thing called let me write down. Okay, do you all remember this? Energy in the internal store. Okay, energy in the internal store. Clear about this? Okay, this energy in the internal store, okay, is consists of two things. Okay, so for each state, they have energy in the internal store, or you call it in short, internal energy. This is equal to the kinetic energy plus potential. Okay, let me write down again. Is equal to the energy in the kinetic store plus energy in the potential store. Okay, so why am I explaining this? Let me explain to you all. Okay, so all of these state of matter, okay, solid, liquid, and gases, the total energy that they all have is called the internal energy or energy in the internal store. So energy in the internal store depends on two things. It depends on the kinetic energy as well as the potential energy. Is that clear? Okay, so when we talk about the least energy here, we are saying that solid has the least energy in the internal store. Okay, when we talk about the gas has the most energy, it means that gas has the most energy in the internal store. Okay, so even though all of the particles here are vibrating or moving, okay, or moving freely, the gas itself, the particle are actually moving the fastest. So the gas has the greatest kinetic energy or energy in the kinetic store. So the greater the kinetic energy, the higher the temperature. I repeat myself again. The greater the particles kinetic energy, the higher the temperature. Are you all with me? Okay, so between solid, liquid, and gas particle move faster compared to liquid particle compared to solid particle. So solid particle actually vibrate the slowest. It actually move the slowest, okay, compared to liquid and gas. And because the gas is moving much faster, the gas particle is moving much faster, so therefore gas has the highest temperature compared to liquid and solid. Are y'all with me? Okay, so let me explain a little bit more. When a solid has a certain amount of energy in the internal store. So when you supply thermal energy to the solid, okay, the particles will start to vibrate faster and faster. So when the particles vibrate faster and faster, the temperature goes up. Okay, the temperature goes up. So it reached to a point where where it doesn't vibrate any faster. And that is when the internal attractive forces start to break. Okay, so when it starts to break, the potential energy, the potential store starts to increase. Okay, so your thermal energy is actually supplied to the solid. Okay, your thermal energy supplied to the solid. Instead of making the particle move faster, the particle is already at the maximum kinetic energy. It doesn't move any faster. So the energy is used to break the strong attractive forces between them. So when the energy is breaking the strong attractive forces between them, the particle gain potential energy in the potential store. So when these strong particle attractive forces are broken, the particle actually gain energy in the potential store and it becomes a liquid. Are you clear with me? So there are still forces between them, but the forces is now broken. Okay, so the whole thing will now have more potential energy. Okay, and that potential energy is used to break the attractive forces between them. Okay, once all the attractive forces between them are broken, when the particles can slide over each other, then as you supply more thermal energy to the liquid, the particles will actually move even faster. So that is what happened when the liquid gain energy. Are you all with me? So it actually moves faster, but the attractive force between them remains the same, but it's weaker than before. It is weaker than before. So as you keep on supplying thermal energy to the liquid, the particles will move faster and faster and faster. The kinetic store energy, the kinetic store will increase, and therefore the temperature of the liquid will increase to a point that it doesn't move any faster. The thermal energy that is given to the liquid will be used not to increase the kinetic store, the energy in the kinetic store, but to increase the energy in the potential store by breaking the attractive forces between them. So when the strong attractive forces between them is broken, now they are able to move freely. Is that clear? And that is when the liquid become a gas. And once all are broken, when you supply more thermal energy to this thing called gas, the particles itself will move faster and faster and faster. Are you with me? Okay, as they move faster, they gain energy in the kinetic store and their temperature goes up. So my conclusion is all matter, M-A-T-T, has an internal energy. Internal energy consists of two things, either kinetic energy and potential energy. As you supply kinetic energy, okay, as you supply kinetic energy into a solid, the particle move faster, the kinetic energy increases, the temperature goes up. Then once it reaches the melting point, the thermal energy is used to break the attractive forces between them. Okay, that is what happens when it melts. So when all the forces are broken, the particles are no longer fixed in a position. They can actually slide over each other. They now become a liquid. They have fully melted. So as you supply more thermal energy or more heat to the liquid, the particles will move faster and faster. So as it moves faster, the kinetic energy increases, the temperature goes up. So if you keep on supplying thermal energy to the liquid, the temperature goes up all the way where it doesn't go up anymore, where the particles doesn't increase in the speed anymore. That's when you start to boil. So when doing the boiling process, the energy, okay, is actually used to increase the potential energy rather than the kinetic energy. That is to break the attractive forces between them. Once you break them, the particles can move freely. So when you boil, the particles are now free. The particles can move even faster. Okay, so now they are free. Okay, and once all the particles are free, the liquid is fully boiled. Okay, so what happens next is, if you supply more thermal energy to the gas, the particles will move faster and faster, and your kinetic energy of the particles will be higher. As the kinetic energy increases, your temperature goes up. Are you all with me? If you're clear about this kinetic particle model, give me a thumbs up. Zixuan, are you okay? Okay, let's reverse. Let's reverse. In a cold environment, right? Gas has a higher temperature than the surrounding. So thermal energy will actually flow from a higher temperature to a lower temperature. Am I right? So when the gas is in a cold environment, the gas will lose thermal energy. Because the surrounding has lesser temperature, thermal energy will be lost. Okay, when thermal energy is lost, the particles become slower. Okay, it becomes slower, the kinetic energy is lesser, therefore the temperature drop. Is that clear? Then if it continues to lose thermal energy, you reach a point where the gas starts to compress. Sorry, not compress, it starts to condense. So when the gas starts to condense, as you lose more energy, you still remain moving in the same speed, but the potential store will actually reduces. Can you see down here? This one has the most energy, this one has the least energy. Can you see that? Okay, this one has the least energy, this one has the most energy. So when it doesn't slow down anymore, okay, when you loses more thermal energy, then the forces between them will start to become stronger. So they will start to form stronger forces between the particles. Okay, so the whole thing just go in reverse. Are you all clear? Okay, until that you take out all the energy, when there's no more energy store. Okay, when there's no more energy store, your particles or your matter would be, okay, when your internal store has 0 joule of energy. Let me write down. When this becomes 0, meaning that this is 0 and this is 0, this is when your temperature is at 0 Kelvin. Okay, when your temperature is 0 Kelvin. So what is 0 Kelvin? 0 Kelvin is the same as negative 273 degrees Celsius. So when your metal is at 0 Kelvin temperature, remember Kelvin is the SI unit of temperature, not degrees Celsius. Kelvin is the SI unit for temperature. Do you remember that? When your object has 0 Kelvin, the object, the particles has no more kinetic and potential energy. He has no more energy at all. It will be no more vibrating. It will be no more moving. So in the practical sense, this is impossible. Okay, a solid will still vibrate very, very, very slowly. So the temperature, the lowest temperature that human can achieve so far is not 0 Kelvin, but 0.0000000 is a very, very small number Kelvin. Are you clear? Are you with me? Okay, so when an object has 0 Kelvin, it means that each particle stops vibrating. Okay, and that is not possible. So do you understand the meaning of 0 Kelvin and why Kelvin is the SI unit and not degrees Celsius? Because when K and the temperature is 0 Kelvin, it means that there's no more energy, no more internal energy in the matter. Is that clear? Okay, so I've finished talking about the kinetic particle model and to relate to the property of the solid, liquid, and gas. I actually went a bit further to explain about internal energy. And I talk about the internal energy is made up of kinetic energy and potential energy. This one actually should be the next topic. But I just try to add them together for you to appreciate how energy is related to this model. Because the model has at least 3 components. Okay, the circle, the sphere represent the particle. Okay, the line or the spring between them represent the forces between them. On top of that, this model also talk about the energy, the internal energy of the model. Okay, so I just add in this energy in the internal store to let you have a appreciation. Okay, what is this kinetic particle model is about. Okay. Next thing I'm going to share about is all the circle, these spheres, they all represent atoms. And atoms are all very small. Okay, the best microscope itself is not able to resolve the detail of a atom. Okay, so we have never able to observe atom before. Okay, but how do we actually notice that the particles actually move? Okay, so there is evidence on how the particles can move. Okay, so what is the thing that we're going to learn about? Hold on for a while. Okay, let's go back to this preview. Okay, so I've used the kinetic particle model to explain, to describe why a solid is solid, why a liquid is liquid, and why a gas is gas. Okay, due to the arrangement and motion of the particles. So I use the arrangement and motion of particles to explain why a metal can be in solid state, can be in liquid state, as well as the gaseous state. Okay, so besides the arrangement and motion of particles, we also talk about the forces and the distance between the particles. Okay, so far, are you okay? Are you with me? Okay, so can you see the distance between the particle is the closest for solid and you have the strongest attractive forces. Therefore, gases, they are further apart. They are very far apart. Okay, and they have very weak forces between them. Okay, so this screenshot, do you want to take picture again? Okay, I give you all about 10 seconds to do so. Okay, let's continue. Okay, so we're going to talk about, okay, so we have done with A, we have done with B. Okay, I actually talk about D. How a temperature of a body is due to the kinetic energy of the particles in the body. So I've covered D already. Are you clear about this? When the particles is moving faster, it has a greater kinetic energy that will result in a higher temperature. That's all. Full stop. Okay, so I've already covered D. And okay, so we are using the particle model to explain how the energy itself actually determine the temperature. So when the kinetic energy is high, they are moving faster and faster. They have a greater kinetic energy, and therefore the temperature rises. Okay? Now, we are going to talk about how are we going to prove that there are random motion of molecule in a in a liquid or a gas. Okay, so basically Brownian. Okay, Brownian come from the guy called Robert Brown. Okay, so Robert Brown in 1827 observed something. So he uses a microscope and observe pollen grain in water. Okay, so they observe pollen grain in water. Okay, what he observed is that the pollen grain is not moving in the water. So you actually use a microscope, you will see that pollen grain is very small, right? Water, you cannot see the particle because water particles can't be resolved by a light microscope. Okay, so what happened is that what Mr. Robert Brown observed in 1827 is that the pollen grain, which is much bigger than water molecule, because pollen grain is made up of a very complex thing, right? It's made up of a lot of things. Got the skin, okay, got the things inside. Okay, got all the things inside for you to fertilize your flower, correct? So pollen grain is made up of a lot of atoms. So it's much bigger than water particles. Okay, so what he observed in the microscope is that the pollen grain actually move in funny motion like this. So what he actually observed is that the particles are moving in a random motion. Okay, it's moving in a random motion, okay, in a constant random motion, and it keep on changing direction. Okay, so this motion is named after this guy, Robert Brown. Okay, we call it the Brownian motion. Okay, so in school, if the teacher were to conduct experiment on Brownian motion to observe why would the pollen grain reach one point you change direction, then reach another point you change direction again. What is it causing the Brownian? What is causing the pollen grain to actually keep on changing the motion? Okay, so besides observing pollen grain in water under a microscope, another thing that you all can do is to observe, okay, observe dust particle in air. So you just use a microscope and observe dust particle in air. You also move in a constant random motion. So what actually is happening? Okay, okay, this one a bit too much. Let me redraw. So this guy, maybe move here, then move here, move here, move here. It is very random. Okay, so what's happening here? This pollen grain is moving from here to here. Then it starts to change direction. So why does it change direction? Because it hit something. So what is the thing that it hit? Okay, so what's the thing that he hit? Okay, so Brownian motion shows that water is made up of particles. Okay, that is what Brownian motion actually discovered. Okay, or proof. It proved that water is made up of many, many particles. So when the pollen grain or the dust is moving, you actually hit the particles of the, in this case, water particle. Then therefore it changes direction. Then when it changes direction again, why? Because it hit another particles of water. So it keep on changing direction because it keep on hitting the particles of water or the particles of air. Okay, and this funny motion is observed because we cannot see, okay, the particles of water and air as they are very, very small. But we can see their effect, okay, from this Brownian motion, because the pollen grain or the dust keep on moving in a constant and random motion. Okay, it's moving in a constantly in a random motion in all direction. Okay, are you clear about this? Okay, so Brownian motion, okay, got two things. It means that the pollen grain or the dust is moving constantly. It's always moving constantly and randomly. Okay, this is a two word. Moving constantly and randomly in all directions. Okay, so I repeat again. Brownian motion means the particles is moving constantly and randomly in all directions. So this actually prove or try to prove that, okay, the water or air is made up of tiny particles called atom or molecules. Is that clear? Okay, so if you all understand about this Brownian motion, give me a yes reaction. Okay, we understand this idea about Brownian motion, give me a yes reaction. Thank you, Sixian and Yiqi. Wei Hong and Siren, are you okay? Okay. Where do the atom, okay, she asked me a question, where do the atom gain the kinetic energy? Okay, so kinetic energy is how it moves, right? Okay, so how does atom, okay, or the particles gain kinetic energy is when we supply thermal energy to the particle. So thermal energy could be like fire. We supply heat to the particle. So when we supply heat to the particle, it causes the kinetic energy of the particle to increase. So when the kinetic energy of the particle increase, the temperature increase. Okay, Siren, did I answer your question or did I don't understand what you are trying to ask me? Okay, so Siren asked me, how do the particles gain kinetic energy? So when we supply heat to it, or we supply thermal energy to it, just like putting the particle above a fire. Okay, so when you do that, the fire transfer thermal energy to the internal energy of the particles. So the particle itself, the internal energy consists of two parts. Okay, if the kinetic energy can increase, the temperature will go up. If the kinetic energy cannot increase, then the body itself will start to change state. Are you all with me? Okay, so today, the last part that I'm going to go through will be to explain the pressure of gas in terms of motion of its particle. So in this case, you're talking about the gas. Okay? So do you remember what is the formula of pressure? Okay, what's the formula of pressure? It's a force over area, correct? Okay, so how are we going to measure the pressure of gas? It's basically measuring the average force acting by the particles of the gas per unit area. Okay, per unit area of the of where it's trying to act. So for example, I got a cube. Inside got gas, right? Okay, so you're trying to find how much the particles, there are a lot of particles inside, they're moving around. So you hit the side of the wall. Okay, so pressure of a gas basically is how much force of the particle is pushing against the area of the container that hold the gas. Is that clear? So if the particles exert a much greater force, it's actually moving faster. Therefore, it's exerting a much greater total force against the surrounding. Or this cube consists of many more particles. So when there's many more particles, there'll be much more forces pushing against the area. So would the pressure go up? Are you with me? Okay, so gas particles will actually move constantly and randomly as well. Okay, you understand that, right? Okay, so the greater the force the particle exert on the surface, the greater the gas pressure will be. Are you all with me? Okay, so at the particle level, because we're talking about kinetic particle model, how do we explain this? Okay, so pressure, gas pressure is the average force exerted by the particles per unit area. Okay, so this explanation, is it clear? Basically, it's the same formula as force over area. So you just need to tweak a bit. It's the gas pressure is the average force exerted by the particles per unit area. So that is the, so this is the how you use the kinetic particle model to explain the pressure of a gas. So basically, a pressure of gas is the average force exerted by the particles per unit area. So are you all with me? Okay, so this whole topic, we are using the particle model or the kinetic particle model to explain the physical property of solid, liquid, and gas. Why solid has the highest density and why gas has the lowest density, we are able to explain using the arrangement, okay, using the arrangement and motion of the particles, as well as the force and the distance between the particles. Okay, based on these two things, we can actually describe the physical property of solid, liquid, and gas. So basically, what are the properties that you all need to know? Solid has the highest density because the particles are packed closely together. Compared to gas, where the particles are far apart. Okay, then we also know that solid has a fixed volume and a fixed shape because the particles are vibrating in a fixed position. Okay, so therefore it has a fixed shape and a fixed volume. Okay, then for liquid, it has a fixed volume but no fixed shape because the particles can slide over each other. And then why gases has no fixed shape and fixed volume? Because the particles of gas are far apart. Okay, are far apart. And they can actually they are far apart in an irregular pattern. Okay, and but the forces between them are very weak, and the particles are able to move freely. Okay, so therefore gases do not have a fixed volume or a fixed shape. Clear? And then how do we prove that this kinetic particle model is true? Okay, so for all the things that you described, why is it true? Okay, because we use Brownian motion to prove that this kinetic particle model is a reliable model to actually explain why solid is solid, why liquid is liquid, and why gas is gas. Okay, so we have this theory, and what is the proof for it? We are using Brownian motion to show that particles actually, the unseen particles actually are moving randomly. Okay, they are moving constantly and randomly in all directions. Therefore, it results in Brownian motion. Okay, it's not the pollen grain and the dust that prove the kinetic model. It's the funny direction that's moving that prove that there are actually particles in the water and air. Okay, so Brownian motion prove that there are water particles and air particles that cannot be seen with our eye in the microscope. And that proves that kinetic particle model is a model that is reliable to explain why solid, liquid, and gas has certain physical property. Okay, lastly, okay, we use the kinetic energy of the particles to explain the temperature of a body. Okay, so the kinetic energy goes up, the temperature goes up. The kinetic energy goes down, the temperature goes down. And lastly, okay, the average force exerted by the particles per unit area will determine the pressure of the gas. If the average force exerted by the particles per unit area increases, the gas pressure increases. How does it work? You either pack more gases in a small area, therefore got more forces pushing against each other, okay, or you make the particle move faster by increasing temperature, for example. Okay, by increasing temperature, the particle move faster, right? So there'll be more forces exerted by the particle per unit area, and therefore the gas pressure goes up. So up to now, I finished the whole topic. Okay, so can you tell me, do you understand what is this topic about? Okay, we are using the kinetic particle model to explain states of matter, to explain temperature and gas pressure. Okay, so if you find today's lesson that help you clear up this whole topic, give me a yes reaction. Okay, I'm going to go through one last thing. I'm going to go through hold on. Okay, I'm going to show you last time there's this topic called temperature, which is no longer shown in your syllabus. Okay, so good news, temperature is no longer tested. Okay, so temperature, this whole topic will no longer be tested in your senior will be tested on this, but you all do not. But let me explain one thing in this topic. Okay, temperature is how hot or how cold an object is. Okay, and then heat can only be transferred from a higher temperature to a lower temperature region. So can you all remember these two things? Okay, temperature is how hot and how cold an object is, and heat energy can only be transferred from a higher temperature to a lower temperature region. Okay, it cannot be the other way around. Okay, heat cannot move from colder to hotter place. Is that clear? So can you all remember these two things? Okay. Then kinetic model of matter. So I mentioned this. Okay, you all look at this. I'll give you all the slides. So from here, I already explained everything. Do you all need me to explain anything from these 3 pages? Okay, so I just show you quickly. Okay, Brownian motion. Okay, Brownian motion. Why the particle of the smoke, okay, the smoke in the air, why it move randomly is because air molecules were hitting them randomly. We cannot see the air molecules. Okay, so the Brownian motion refer to the observed random motion of the particles in a fluid. Okay, so this itself, we use this Brownian motion, okay, to explain that air particles are in constant random motion, and the air particles keep on hitting the smoke particle continuously, causing the smoke particle to move continuously in random direction. Okay, so pressure in the gas. Okay, this one we will not go through, but let me just show it to you. As okay, we'll skip this. Okay, so basically this is all about the kinetic model of matter. Okay, so before we go, I have a few questions for you all. A few checkout questions. Okay, number one. Okay, number one. How much did you learn today? Okay, give me a scale of 1 to 10. Okay, how much do you learn today? If you learn nothing today, tell me 1. If you learn a lot of things today, give me 10. Okay, and then how well Mr. Chu teach today? Okay, if you think I teach lousily, give me 1. You think I teach very well, give me 10. Okay, then once I call your name, you may leave the class. I would like Yu Qi to stay back. Okay. Shixuan, you may go. Thank you. Rui Hong, you may go. Yiren, you may go. Okay, thank you everyone. Good night.